I'm Nathan Ness. I'm a technical product manager in the Cloud Native Applications business unit. So I focus on PKS that was recently announced, as you probably saw during the keynote today, or it was actually announced in Vegas. But I'm part of the technical product management team here. I've been at VMware about 6 years.
Cool. Yeah, I'm Matt McNeely. I'm a product manager over at Pivotal R&D. I do a lot of work on service brokers, which we're going to talk about a little bit later on. I'm actually also on the project management committee for the Open Service Broker API, an important component in kind of the PKS world. And yeah.
Okay. So full disclaimer here, don't buy things based upon what we say, because obviously PKS isn't out yet, so there'll be some forward-looking stuff inside this presentation. So we built this talk around basically how we got to where we're at today. So we're going to kind of do almost like a little history lesson of the what and whys, starting with the software-defined data center, and then moving on to BOSH and Kubernetes, and basically how we ended up with PKS today. So the what and why of the software-defined data center, and if anyone hasn't heard of this, the SDDC in this room, you probably haven't been at the last 4 or 5 VMworlds. I think it's been the theme for a very long time, and I think how we got there, and really the benefit of that was to abstract hardware, right? The whole goal of compute virtualization was to not only gain cost and efficiency, but also gain a lot of agility. I think that was kind of an after fact. It's like, oh, we can now program things programmatically through plugins and drivers and APIs now that we have this flexibility and this abstraction of hardware, right? It's like we don't even know what's happening underneath it from an infrastructure standpoint, and maybe should we even care, right? Virtual machines are moving around all the time. Same thing from, now that we have NSX, we can create virtual abstractions from networks and switches and firewall policies, and all of that can be automated through APIs to include Kubernetes. So this was a common theme here, even back from the NSX. It's like, okay, yes, we've done compute virtualization, but what about the rest of it? You really need the foundational pillars of compute, network, and storage to really provide that abstraction to basically virtualize and make infrastructure as code throughout the environment. And I think that's kind of the goal here, is to make sure that don't stop at compute virtualization, because you're going to need all of those other abstracts to provide full functionality inside of a Kubernetes environment. And so really when we're looking at this, inside of this, when we have the abstraction, right, we have the infrastructure consumer, and we have these tools that are either in a CI/CD pipeline or maybe just homegrown tools such as an IaaS platform, right? And then we have some operations teams that are managing compute, network, and storage. So typically this request is going to go through some CMDB, some ticketing process, and then the ops teams are going to get this request, and then what happens here? And so typically this is what happens today, right? People are pounding on the keyboards, and this may take a while. It depends on your environment. And so inside your environment, then what happens, right? You get days and variability, and everything is happening most likely in a usual fashion if you're not using the software-defined data center, maybe some type of IaaS platform or container platform. So the goal here is we don't want necessarily long-lived infrastructure. We want fast, we want agility, right? We're going through this digital transformation, and what provides that? And so now if we're going into the SDDC, we can say, let's make that same request and turn that into infrastructure APIs or cloud APIs, right? So now I can describe the infrastructure, not only the VMs that we want to deploy or the networks that we want to deploy, but also the security policy, load balancing can go into this request. So then if things change or I need to provide some type of audit, it's very easy to do, right? I can go into my version control or my Git repository where this was and examine what exactly changed inside my infrastructure. I'm not digging through logs over here on the end to see what changed or who did what when it's done manually. So with that, we get fast and predictable infrastructure, right? We can tear these things up and down very, very quickly because they're just a set of APIs that we can utilize inside of our environment. So again, short-lived infrastructure, moving things into infrastructure as code, this is really what the software-defined data center has provided us. Really the flexibility to provide this programmatic infrastructure to our customers. I'm going to hand it over to Matt.
Awesome, thanks Nathan. So before I get into BOSH, can I have a quick show of hands who's heard of BOSH before? All right, and now hands up if you've used BOSH before in your environments. Okay. So you can probably check Twitter for the next 10 minutes while I quickly go through kind of the what and why of BOSH. And to start with, I want to kind of talk about why BOSH has come about and why it was built a long time ago now. So coordinating a few things in your kind of data center is OK. You have a few VMs, a few servers, a few applications, a few development teams. And this is possible to do, right? There's tooling out there which will help you do this. But when your company grows and you have tens or hundreds of development teams, with thousands of applications, all that need databases, messaging queues, configuration servers, then coordinating all of that stuff together and keeping the lights on is really, really difficult. So there's a few things to do this successfully that operations teams need to be able to do, and that development teams need to have access to. The first thing they need is they need to be able to create releases of their software. They need to take their code that they want to run, combine that with all the binary assets, configuration files, database connections, and they need to package that up into something that you can deploy anywhere. We refer to that as the identifiability of the software release. Second thing you need to be able to do, you need to be able to integrate that with any other dependencies it needs, some third party, and you need to be able to reproducibly create a single package that you can deploy. And finally, you need consistent deployments. You need to be able to say, right, here's my source code, here's the dependencies, take it, bundle it up, go and run it on my infrastructure of choice, whether that's AWS, vSphere, and go and deploy it. And I don't want to have to think about what's happening. I don't want to have to worry about what's going to happen when I do that. So these things you'll probably recognize. These like three terms, identifiability, reproducibility, and consistency, are all from the definition of release engineering, a very important kind of software engineering discipline. And that gives operations teams one very, very important thing, which is boring deployments. Okay? They don't have to think about this. This can happen in the background. This helps empower development teams to be able to deploy their software tens or hundreds of times a day without having to let operations teams know in advance that they're going to do it and how many times they're going to do it, what the impact is. So I know there's a lot of tools out there which help you do this kind of thing or help solve some of these problems. We have tools like Terraform, great for building out the services, building out your server, sorry, but they're not great for packaging up your software. Tools like Docker, which on the kind of other hand, packaging up your software consistently is great, but they don't deal with the underlying infrastructure. And then we have tools like Chef and Ansible, great for keeping your infrastructure happy in a known healthy state, but they're designed for the services they're running on, not for the services you want to run on them. And we believe there's one tool that can do it all, which, surprise, surprise, is BOSH. So BOSH is an open source tool for release engineering, deployment, lifecycle management, and the monitoring of distributed systems. Okay, but what does that really mean? I think to really understand the power of BOSH, let's take a quick look at how it actually works in reality. So the most important piece of this kind of BOSH puzzle is the director. This is like the conductor of the orchestra. It makes everything play nicely together. It manages your entire infrastructure state. You obviously have your release software, the code that you spent, poured many hours into writing, all its dependencies bundled up into that kind of identifiable release we talked about earlier. And the first thing you need to do is upload that to your director. Now you need something else. You need a stem cell, a BOSH stem cell. You can download them for free from bosh.io. There's many different types. There's typically kind of a bare minimum skeleton operating system, highly secure, configured with a few kind of pre-installed utilities that are useful for BOSH. A little bit of a wrapper in there for the infrastructure you're using, let's say vSphere. And you upload that to your director as well. And finally, you have what we call the BOSH manifest. This is typically a pretty big YAML file. This defines everything you can think of to do with your software and where you want to deploy it. The processes you want to run, the kind of periodic or scheduled jobs, the hardware configuration, network configuration, firewall policies, the size of the VMs, the number of the VMs you want to provision. Again, this is kind of abstracted away from the infrastructure you're going to run this on. And again, you upload that to the director. Now there's one more bit of magic, which is you run one command, BOSH deploy, and BOSH converges the world onto your desired state. So it'll slowly, so over time, when you run BOSH deploy over and over again, BOSH will look at your manifest, it'll see what's changed, it'll safely roll these things out across your entire infrastructure. And this gives operations teams one very, very important thing, which we often refer to over the past few years as the day two experience. I'm sure you've heard this a lot. What we think this means for operators is that they get a declarative and self-healing system. BOSH monitors the health of the VMs. If a VM dies, BOSH Resurrector brings it back up and puts the software back on it. If a process dies, then Monit will do the same thing, and it will restart that process. There's another thing they get, which is rolling updates. So BOSH uses a canary updating system, so when your developers have new code to write, you can run BOSH deploy. That update will get slowly rolled out to one VM at first, called a canary. It'll check that that's happy, check it stays alive, and then over a configurable period of time with configurable number of VMs being updated, it'll slowly roll out across your entire infrastructure. You also get scalability. So let's say you've got your infrastructure set up, your company starts taking off, you're getting hundreds of API calls a second, you need to scale up. All you do now is you go into that BOSH manifest, change the number of VMs, change the size of them, run BOSH deploy, and that'll spread throughout your entire infrastructure safely and securely. So hopefully, for those who didn't know what BOSH is, that gives you a reasonable overview. And now Nathan's going to take us through Kubernetes.
Thanks. So the what and why of Kubernetes. How many people are using Kubernetes today? Okay. So when we're looking at this, it's one of those things where we're looking at it as a container as a service platform, right? And it came from Google. And the picture here signifies what it actually means, a helmsman, right? And they kind of play on words, right, where they're the helmsman of the container ships out in sea. And so that's where Kubernetes, the word Kubernetes came from. But when we're looking at this, it's like, why do we need Kubernetes, right? When we're looking at these, I have thousands of containers. I need something to schedule them and orchestrate them, right? I don't need to manage them individually. Like, we don't manage our VMs individually on VM per basis, right? We make tools like vCenter DRS and HA and all those functionalities that we are so used to in vCenter just handle it. And so we need that same type of orchestration platform for container workloads as well, right? We're not going to manage containers individually. And so this is exactly where Kubernetes comes in. And so Kubernetes is an open source platform for managing, orchestrating, scaling out container workloads. Okay? The capabilities to deploy applications quickly and predictably, scale the applications on the fly. I can do a rollout and roll out my application to X percentage. I can pause that rollout. I can undo that rollout. And so it provides a lot of flexibility where, again, I'm not doing like individual Docker run commands and throwing out 1 and 2 and 3 containers. I can orchestrate many containers at the same time and provide things like east-west load balancing and scheduling and HA-like capabilities for these containers on top of Kubernetes. Again, roll out new features, and again, optimize your hardware for only using the resources you need. Right, and this is where we're talking about even what Matt just talked about, where we're scaling out the cluster. Right, we shouldn't have to worry about scaling. We shouldn't have to worry about scaling our application. So our application is going to be scaled by Kubernetes, but our infrastructure is going to be scaled by things like BOSH. So again, the role here sits at the container as a service layer. Right, this is an orchestration platform for managing your container workloads. And so I'm going to quickly go over just a 10,000-foot view on how Kubernetes works. And so Kubernetes works as desired state management. It's always watching. Okay, so again, just like BOSH is going to be putting the infrastructure in desired state, Kubernetes is going to put the containers and the services in their desired state. So it's based upon a cluster. So the lowest unit of deployment I can have in Kubernetes is you're going to deploy a Kubernetes cluster. Within that cluster, you're going to have a worker. And that worker has an agent called a kubelet on it. And think of the kubelet as like host D or something talking back to the master. Right? And then we have the deployment and the configuration file. These are the desired states, right? And so when I submit this into Kubernetes, it's going to say, I want this container image, I want 3 replicas, which is going to say 3 pods is what it's called on top of here, and it'll deploy that on top of my workers. Again, the container image, these run as a pod, and a pod consists of 1 or more containers inside of it. It can be one-to-one or it can be one-to-many. But a pod is very tightly coupled with each other. It shares local host, it shares RPC, and it shares different namespaces. So it's a very tightly coupled grouping of 1 or more containers. Replicas. So again, we want to take care of like high availability within this. So if our desired state says we want 3 replicas, if one of our pods goes down, the Kubernetes cluster should spin that pod back up and maintain that desired state. So here we go. We have each one of our workers here inside the cluster with the kubelet attached to that. I have my deployment file with my desired state on what I want to deploy for my application. This is going to contain things like a network policy, contains how many images I have, which images I want to use. It's also going to contain things like the service on how a front end is going to talk to a back end. It will also have labels in there. And so again, from a management standpoint, this is exactly where you're going to want to put all your labels and all your metadata can be inside of this, and again, checked into version control like we talked about before. When this hits the Kubernetes API, the master is going to have consists of a scheduler, and it's going to schedule these pods on top of the workers. So as you can see, the scheduler is going to spread out the 3 replicas across my workers. If it doesn't have enough room to schedule across in an anti-affinity pattern, it will place all the pods on as many workers as it can to provide as much anti-affinity as possible. I can deploy another container image again. If a worker goes away, what happens in this, the Kubernetes master will reschedule these pods on different workers. Now, what's interesting to note is, in your environment, nothing is going to spin that worker back up, right? But we have something that will spin that worker back up, right? We're going to talk about, self-healing capabilities of that, because not only do we want our cluster in desired state, but we also want our infrastructure in desired state as well. Okay, I'll pass it back over.
Awesome. Thanks. Okay, so we've done BOSH, we've done Kubernetes, and the next thing that comes in that list is Kubo. So again, I think it's good to talk about why Kubo came about before exactly talking about what it is. So if you're involved in the Kubernetes community, you know who Kelsey Hightower is. He kind of summed it up in a way that I thought was really nice in this tweet, which he said, Kubernetes sits on top of your infrastructure, provides an API for managing your application and containers. The hardware and networking, so the infrastructure though, are on you. So he put together a repo, basically a tutorial about how to spin up a brand new Kubernetes, and it's called Kubernetes the hard way. The guide even says if you want an automated command to do this easily, use Google Container Engine. Otherwise, look at these guides. So I thought, right, I'll do this. Can't be that hard. There was 11 markdown files at the time to do it. Now there's 14 as of a couple of days ago. I got it up and running. It was possible. It took me a little bit of time. There's lots of opportunities to make mistakes with network policies, IP address ranges, things like this. It gets a little bit difficult. If I worked in an organization where I had my development teams coming to me saying, hey, I want my own Kubernetes cluster, and so do I, and I had to do this multiple times again, I'd be pretty unhappy. So we spoke earlier about kind of Kubernetes. It's a very powerful container orchestration system. We spoke about BOSH. It gives operations teams happiness. It gives all those kind of day 2 value. So what Kubo is very simple. It's just Kubernetes on top of BOSH. BOSH deployed Kubernetes. It's open sourced and managed under the Cloud Foundry Foundation. Anyone can go and download it. And using BOSH deploy, you can spin up your own Kubernetes cluster. Now, there's a lot of kind of experience that's being put into this. Pivotal have spent a number of years now kind of selling into Fortune 500 companies. I think over half of the Fortune 500 now using Cloud Foundry, also deployed using BOSH. And Google, with Kubernetes, it's basically they've learned from their own internal tool, Borg, which they use to manage their own data centers. And they put that into Kubernetes. This is a really, really powerful tool. And the problem it solves is it gives you a uniform way to instantiate, deploy, and manage an HA Kubernetes cluster. This could be on any cloud, it could be on-premise, on vSphere. Again, BOSH abstracts that away. So you can choose your stem cells, you choose where you want to deploy it, you can use this Kubo release and deploy your Kubernetes clusters anywhere. And that's it. Kubo is pretty simple. Just Kubernetes deployed on BOSH. So now we'll talk about PKS, the final piece of this kind of big puzzle. So you probably heard about PKS now, Pivotal Container Service, launched alongside with Google and VMware a few weeks ago, and then again over the last couple of days. So again, talking about why these things come about, there was two major problems we saw with Kubo and enterprises who want to run Kubernetes at scale. The first of those is manifest. So I sold BOSH earlier saying how great it is, and it gives you all these like really nice day two operations themes. But there is a problem, and BOSH manifests are not very fun to write. If you look at the Kubo, you'll see there's some pretty large YAML files in there defining the underlying infrastructure. Open source Cloud Foundry, which is built on BOSH, that's 6,000 lines of YAML for one Cloud Foundry installation. And if any of you have written a lot of YAML, you'll realize it's pretty painful. No one really wants to do this. That's one problem. Writing manifests is pretty difficult. If you wanted to deploy Kubo over and over again, you'd be taking manifests, changing them subtly in different ways, and then if you had to debug something, it's going to be pretty hard to do. So the second big problem is tenancy. So we know that everyone will want their own Kubernetes cluster. It's a great tool. But for the reason described before, with all these different manifests, that's going to be really difficult to do. But we don't want to just spin up one huge Kubernetes cluster using Kubo, but like, thousands of VMs sitting behind it, so you can have thousands of pods running if you wanted to, because that doesn't really help your development teams. If you look at like this, we've got this move right now to kind of these balanced teams. They manage their own life cycle of their code. They need confidence that they can deploy their code without affecting other teams, right? They need some kind of isolation of the software that they want to run, especially in production. Likewise, they want to be able to run their code without worrying what some other team's code is going to do to them, right? If they're sharing one big VM, then all of a sudden one application goes wild, starts using all those resources up, and everyone else's containers, they start to die, they start to degrade, and nobody really knows why. And as an application developer, that can be very, very frustrating. We've had this problem at Pivotal, so we built something called the On-Demand Broker SDK. What this does is, again, powered by BOSH, you can say, hey, right, I want to deploy a new MySQL instance. You can go and run that. You run something in the Cloud Foundry world. You'd run CF create service MySQL, and you get a brand new, isolated MySQL cluster that you can plug into your application and not worry about any of these kind of multi-tenant problems. So that was a little bit kind of a sidetrack, but it does tie in to Kubernetes and PKS. If we think about what development teams need, there's a few things. They need security. They need to know that they can deploy their application and prevent it from getting unauthorized or unauthenticated access. They need compute performance isolation. Again, not only to isolate their own code, but to make sure they're not going to degrade other people's, other applications team's code. Then they need things like network and storage performance isolation. These are equally important as for actual performance of their applications, as well as security, as well as in many cases, actually legal and compliance reasons. And that's why with Google and VMworld, VMware, Pivotal, and Google and VMware recently announced Pivotal Container Service. Okay, so I'm sure you've all heard about that. Let's take a look under the hood, because that's much more interesting than that slide. So we know Kubo is this BOSH managed Kubernetes environment. What PKS is it wraps that up on your infrastructure of choice like vSphere using the power of BOSH, and it gives you a CLI through a service broker to actually provision Kubernetes clusters. So what a service broker is, a service broker is an API. There's a contract called the Open Service Broker API. It's a standard that's been around. It came out of the Cloud Foundry Foundation again about a year or so ago now. It's now being worked on by Google, Microsoft, Red Hat, IBM, and a few other companies. And it's, in a nutshell, it's 5 endpoints. It allows you to provision, update, and delete a service that sits behind the service broker. And it allows you to create and delete bindings. And the best way to think about bindings in almost all use cases is it just returns you a unique set of credentials for accessing that service. So lots of things can sit behind service brokers. You could have databases, configuration servers, messaging queues. But in this case, we have a Kubernetes cluster, which is Kubo, because it's deployed by BOSH. So the first thing you do is you use the PKS CLI, you call into a service broker, and you say, hey, I need a new Kubernetes cluster. Please go and provision it for me. And using BOSH, BOSH will get that updated manifest. It'll slowly converge on that desired state, and it'll spin up that brand new Kubernetes cluster. And you want to use that cluster while you use the existing toolchain, something like Kube Controller, and you can immediately start talking to that cluster, deploying your containers, checking your pods, whatever else you need to do. Now, the second development team says, hey, I'm really jealous of that. I want one too. Okay, so you spin out some more, and then you spin up some more. And each time you do that, you're just running one PKS CLI command to spin up a brand new Kubernetes cluster. And your development teams look like that. All right, so this is still in development. So again, don't take this to be exactly what it's going to look like, but I thought it would be useful to actually see how you can interact with this come the end of the year. So the first thing you want to do with the PKS CLI is deploy a new Kubernetes cluster. That'll be something like PKS create service, Kubo on demand, small, my Kubernetes. So that small is something in the Open Service Broker spec. It's called a plan. You can configure different plans in a service broker. Typically, we use things like small, medium, and large to like specify the size of a cluster or the size of the VMs it's running on. You can put anything you want there, though. The next thing, you need to get access to that Kubernetes cluster. So when I spoke about bindings before, which is an API endpoint in the Service Broker API, you can do PKS create service key, my Kubernetes key. That'll call the service broker. That'll ask for a new binding to the cluster that you've specified, in this case, my Kubernetes, and you get a unique set of credentials back. This is also quite neat because different development teams, let's say they did want to talk to the same cluster. They were using a shared resource, they had some shared code. You could give them each a unique set of credentials to access that, and then revoke those service keys as and when you need to. And then, as I said before, the existing Kubernetes toolchain can be used to actually interact with your new Kubernetes cluster. And that's it. That's PKS.
Any questions?
Yeah,
can you compare this in my thought, like, can you compare this to OpenShift? Is it a competitor, or is it like, or is it, your thoughts on that?
Yeah, I would say it's like OpenShift as far as like Kubernetes. OpenShift uses Kubernetes underneath the covers as well. It also provides some PaaS-like stuff, but PCF would provide the...
BOSH would be kind of comparable to Ansible, how they use Ansible to deploy OpenShift.
Yeah, that's exactly it.
So
like,
just draw the parallels on that.
Yeah, no, that's exactly right.
I think this morning in the keynote we saw also a graphical user interface to deploy a Kubernetes cluster.
Mm-hmm.
So is this GUI also part of the package or not?
So,
graphical user interface, yeah, there will be a UI that you can log into from vSphere admin type view, and you can log in, and it'll be a very similar thing. How many workers do you want? What the t-shirt size is or the plan size is? How big do you want the cluster? So yeah, there will be a CLI, API, of course, and a GUI.
Hi. I want to ask, can you compare BOSH with your solution?
sorry, what's the question?
Can you compare Kubo with PKS? Yeah.
Kubo with Kubernetes?
No,
with PKS.
KPS.
Okay, so PKS is using Kubo.
Yeah, I know, but what more we get if we get PKS?
Okay, so from my perspective, you get that kind of you get the management layer over Kubo. So Kubo is that open source BOSH release, just like you could download the open source Cloud Foundry release today, which uses BOSH. But there's a lot of stuff that goes on top of that, which is like actually managing this at scale. If you want multiple Kubernetes clusters, you want to deal with things like having a tool to actually provision those. We have like VMware have tools. We have tools like Ops Manager, which we use to deploy PCF, which you can probably use to deploy PKS as well. There's a lot more like kind of knobs and settings which are easier to change there than just by going into the manifest files directly. I think the real power is deploying like many of these across different AZs and actually having like an interface to be able to do that.
Yeah. Yeah, exactly. And then also, PKS will come with NSXT integration. So if you want to do microsegmentation at the pod level, that'll automatically be provided. Same thing with isolation. So NSXT with Kubernetes provides a lot of isolation, even if you're creating different namespaces, where in native Kubernetes, that's not necessarily the case. And it also does, obviously it's going to be fully supported distribution of Kubernetes, so you can call for support on any piece of the stack, right? We own it from top to bottom. And there also will be integration with VROps and Log Insight and some of the operational tools that you guys probably have been using.
But give Kubo a go, because it'll be great to get your feedback anyway on how easy you find it to deploy.
Yep.
Could you comment on how the more cloud-native kinds of 12-factor, stateless kinds of app infrastructure into Cloud Foundry fit into the overall picture? Does BOSH provide a way of unifying, looking at a system that might be composed of containerized stuff and not so container-centric stuff?
Yeah, so we're definitely we're looking at ways right now of combining, at least from the Cloud Foundry perspective, Cloud Foundry's elastic runtime and also Kubernetes. So whilst PKS will be a standalone software product that you can go and deploy and just run your containers on, there will also be a way to actually provision Kubernetes clusters through your Pivotal Cloud Foundry installation. And then, although right now there wouldn't be like a uniform user interface, they'd have two. You could either do you could have your elastic runtime as it works today, do your CF push, use all the power of build packs, etc. But what you could then do is, as you would now create any data service, you could use CF create server my Kubernetes. And what we're doing is that would and then get the service key for that. You still have to use the kube controller for the time being. We do want to unify those app developer UXs. But yeah, that's basically how we're envisioning it today. We are also working on kind of the networking policy so that they could actually talk to each other. So you could actually have your Kubernetes containers talking to your applications running in Cloud Foundry.
Hi, if we compare this solution with other container services like OpenShift or Docker, where we do not require a virtualization hypervisor layer on that. It directly installed on the bare metal. And top layer is your Kubernetes or Docker Swarm. So just want to understand, in this solution, we are integrating with NSX and vSphere. So what is the use case of introducing hypervisor layer between the bare metal and container services in PKS?
Are you talking about how it spins up like in vSphere integrated containers as VMs, or?
No, my question is that what is the use case, why we are introducing the hypervisor, what is the use case of integrating the PKS with vSphere hypervisor layer, VMware?
So I think that gets you the ability to scale, create multiple clusters without standing up physical hardware every time you want to deploy a cluster. Because you're only going to have that node or that bare metal worker would be only allowed to talk to one cluster, or would be joined to one cluster. Here we can utilize same things. The NSX integration we can utilize now. We can utilize scaling it out. Basically the agility piece that we talked about in the beginning of having all this underneath a virtualization umbrella. Go ahead, I'll repeat the question.
So this is utilizing NSXT, if I'm not mistaken.
Yeah, the question was, is this utilizing NSXT? And the answer is yes.
Yeah, so how would it deal with advanced party integration for security protections, such things like next-generation firewalls, such as prevention, malware stuff, like the rerouting of traffic for deep inspection, for example?
Yep.
Besides the standard security groups filtering based on IP or VM tag.
Yeah, so a couple of things from NSXT. It doesn't have those partner or that NetX integration yet. That's something that will come over time. But it does provide things like port mirroring. So if you want to mirror a port on a particular pod, you can certainly do that and redirect or mirror that traffic to something third party that's sitting inside the cluster.
So at least inspect.
Yeah. Any other questions?
I think one of the before we jump, one of the cool things to note is that we didn't touch on is that there's a lot of with the Google partnership here, all of the Google services that you get up today, things like anything you see in the GCP console, basically, they're all going to be plugged in to PKS through the service broker interface. So not only can you go and provision your Kubernetes clusters, you can then get those clusters through a project called the Service Catalog to go and provision Google services on the back of that, which is going to be a pretty cool integration there. Sorry, go on.
Is the underlying OS for those clusters, is it Photon? Are you guys using Photon for that, or is it the actual Linux that's laid down? Is it by default Photon, and can that be changed?
So right now it's going to be using Ubuntu. We will certainly support Photon in the future. Yep.
I think his second question was, can it be changed? Do I have to use Ubuntu, or can I have another distribution?
You want to talk about that from a stem cell? I don't know, to be honest.
Yeah, well, I'm sure that will be exposed at some point. One of the kind of the nice things about those stem cells is that, with the power of BOSH, you have this like separation between the actual software you're running and the stem cells. So for those less familiar with BOSH, what that means is, let's say a CVE comes out about the OS you're using. You can actually go and change that stem cell, roll that out, and you don't even have to touch your software. That happens totally independently. So I'm sure the end result of this project is you can mix like intermittently change the stem cells that you're running this whole platform on. I'm not sure when that's going to land. Any other questions? All right.
Oh. Please fill out your survey.
Awesome.
Thanks, guys.
Thanks, everyone.